Hi, we are going to have a quick look at how to measure volatility using the exponentially weighted moving average model. Now, I will show you a worked example in an Excel spreadsheet in a moment. So when we use the EWMA model to measure volatility, what we are saying is the squared volatility, in other words, the variance, the estimated variance equals, we use a parameter called lambda, which can also be referred to as the decay rate. In other words, how important is yesterday's variance in interpreting today's variance. So that's what lambda parameter basically tells us. So when we are estimating volatility using the EWMA approach, what we are saying is the estimated volatility. So let's assume that we are in an end of day today and we want to estimate the volatility for tomorrow. As a risk manager, let's assume that you want to estimate the estimated 1-day volatility for tomorrow. So tomorrow's estimated volatility equals lambda times the estimated volatility squared of yesterday, in other words the most recent volatility estimate, so you square that, and then plus 1 minus lambda times the square of the most recent daily percentage change. Now the daily percentage change, you can also take it as a log of the daily percentage change, which means you are assuming that the day-to-day changes are continuous. So simple as that. Now you can see, so your volatility estimate for tomorrow is based on two different components. One is your volatility estimate for your previous day or your most recent volatility estimate plus the most recent daily percentage change. In other words, if you're experiencing high volatility, you're applying some sort of weighting, in this case 1 minus lambda. Now lambda is a number between 0 and 1, and as we move on I will explain to you what's the ideal value for lambda. There's no one value, but in the industry there are some accepted values that behaves well for a lambda. So lambda is a value between 0 and 1. So you apply some sort of weighting to the most recent price changes, and then also you apply some weighting to the most recent volatility estimate. So that's what we are saying here. A lower value of lambda leads to a great deal of weight being given to most recent daily percentage change. So for example, if your lambda is very small, let's say for example if it's 0.1, what that means is you're giving a 90% weighting for your most recent price changes and you're only giving 10% weighting to your most recent volatility estimate. In other words, you're allowing your model to be more flexible towards daily price changes. But if you think your daily price changes only has a very short-term impact, then you can make your lambda to have a higher value, let's say for example 90% or 99%. That means you're only giving 1% weighting to your most recent price changes. So we will discuss the ideal amounts that lambda can take. But what you need to understand is when we are talking about the exponentially weighted moving average model, we use two inputs. The first input is the most recent volatility estimate. It could have been yesterday's volatility estimate or the most recent volatility estimate and the most recent daily price changes. So here I'm just showing you a very high level example. So let's say we are in end of day 12, and we have a couple of prices here, day 10, day 11, and now we are in end of day 12. So these are the closing stock prices. Now here we are taking the daily return, we are taking the log return, so log today's price divided by yesterday's price. So these are the daily log returns. Remember, when we are taking log returns, what we are saying is the price changes, it's changing on a continuous compounding basis. So we are taking the daily log returns and then we are squaring those daily returns. Now you don't have to take log returns, you could have just taken today's price divided by yesterday's price, but in this example we are taking log today's price divided by yesterday's price. In other words, we are assuming the price changes are continuous. So these are the daily squared returns. So you can see that from day 10 to day 11 the squared returns is 0.9%, and then from day 11 to day 12 the squared return is 2.15%. Now let's assume a risk manager is in day 12, end of day 12, and the risk manager wants to estimate the 1-day volatility for day 13. So if the risk manager is using the exponentially weighted moving average model, remember we said when you are estimating the volatility, the current estimated volatility, you need your most recent volatility estimate. So let's assume your most recent volatility estimate was made on day 12, and that is 1.5%. That's your most recent volatility estimate, 1.5%. So you take your most recent volatility estimate, 1.5%, you square it, and we are applying a lambda of 0.94%. A lambda of 0.94. In other words, we are giving a very high weighting to the most recent volatility estimate. And remember, a lambda of 0.94 is kind of the standard accepted risk matrix lambda value. Now you don't have to all the time use 0.94, you can use any other value, but 0.94 has been tested by experts across various asset classes, and it has been agreed that 0.94 gives a more realistic estimate that is much closer to the actual market volatility. So that's the value we are using here. Remember, as I said, you don't have to use 0.94, but here we are using 0.94. So lambda times the most recent volatility estimate squared, which is 1.5% squared, plus, so remember this 1.5% is from here, that's the recent volatility estimate. In other words, when we were in day 12, we estimated the volatility to be 1.5%. So that's what we are using here, and we are squaring that volatility according to this formula, plus 1 minus lambda, that in other words 1 minus 0.94, and then we have to take the square of the most recent daily percentage change. So on day 12, the most recent daily percentage change was 2.15%. So 2.15% is simply the square of this number here, minus 0.14, 2.15%. So that's what we are using here. So that gives us a variance rate, remember, because we are squaring the volatilities. So when you square the volatility or when you square the standard deviation, that gives you the variance. So that's what we are saying here, variance rate. So the variance rate, in other words, the estimated variance rate, remember these are not the actual, we are estimating. The estimated variance rate for day 13 is 0.15%, and therefore we can take the volatility for day 13, which is simply the square root of 0.15%, which is 3.87%. So using the exponentially weighted moving average model, we can say the volatility for day 13 is 3.87%. Now let's quickly have a look at how we can show this in Excel. So here we are on T0, so today is T0, and we are trying to estimate the volatility for T plus 1. So we are going to use the exponentially weighted moving average model to estimate the volatility for T plus 1. So we need two inputs. The first input is the estimated volatility for T0. Remember, n is T plus 1. So we are trying to estimate the volatility for tomorrow. So we need today's estimated volatility. In other words, what's the estimated volatility number we used for T0 plus the percentage change for T naught. Now here I've taken 250 days, so assuming we have 1 year's worth of stock prices. So from the days goes from 0 up to 250. And then we have closing stock prices for every day. Remember, we said we are end of T naught, so we are end of today, and we want to estimate the volatility for tomorrow. We take the daily log returns. That's the formula. So simply we take the log 1 day's return over yesterday's return. So those are the log returns. Now remember, these days are in ascending order. So this is the latest day. We are in T naught. This is yesterday. This is day before yesterday. Likewise. And then you take the square of those daily returns. Now what we do is we apply a weighting. Now the formula for the weighting is this, is lambda times T. So in this case, you can see here, so lambda times T. So in this case, T is 0. So lambda times 0 multiplied by 1 minus lambda, which is, and here lambda is 0.94, so it's multiplied by 1 minus lambda. Now if you see here, what's happening is the weighting for the most recent price change. So remember, we are in T naught, so the most recent price change we are giving a 6% weighting, and then for yesterday's price change we are only giving 5.64% weighting. And then as we move on, you can see the percentage keeps reducing. So if I just keep coming down, 100 days ago, any price change before 100 days, we are only giving 0.01% weighting. In other words, I mean, here of course the prices are stable, it has not changed according to this, but even if they're changing, for example, so I've just used a flat price here, but even if the prices are changing, what we are trying to say is, so you can see here, if you have a price change, something here, let's assume that the stock price was 200. So you can see from 200 it has dropped to 26. That means the price dropped by almost 200%. So you can see from 26 to 200, that's a 200% jump, and then it has dropped by another 200%. So the squared returns are 400%, but you can see the weighting is 0. That means there's almost, whatever happens far from today will not come into this formula, because we are not applying the weighting. The way the exponentially weighted moving average model works is that if you have an observation far from today, the weighting, since the weighting keeps reducing, they will not impact the estimated volatility for tomorrow. And the concept behind that, or the logic behind that, what we are saying is, something that happened 200 days ago is less likely to happen today, which is sometimes is a bit it can work in your favor, but at the same time it might not work in your favor. For example, COVID-19 stress event was worse than 2007-2018 financial crisis stress event for some of the assets. So in that case, volatility, that event that occurred far back in history, you could say it has almost repeated itself. Now in the exponentially weighted moving average model, we will not factor that in, or we might factor it in, but the way we apply the weighting, we might apply a very small weighting. So that's something important to remember. So once you apply a weighting, so you simply multiply your weighting by the daily returns. That's what we are doing here, the square of the daily returns, and then you multiply your weighting, and then you simply add all your weighting squared times daily return squared. If you add all of them, you will get the estimated variance for T plus 1. Now rather than going through this long method, you could simply use this formula. Now in this formula, you just need simply two inputs. You need yesterday's daily returns. So yesterday's daily returns is simply squared of yesterday's daily returns, that's this here, 48%. And you need yesterday's estimated volatility. So remember, now we need T0's estimated volatility. So here I've shown you. So today's T0. Now what we would have done is on T minus 1, so that's what I'm showing you here. On T minus 1, we would have done the same exercise. T minus 1 means we are here. Remember, this is T0, this is T minus 1. On T minus 1, we would have estimated the volatility for T0. So the estimated volatility for T0 is 17.4%. That's the estimated volatility for T0, 17.4%. So you need this number, that's one input, the estimated volatility, 17.4%. So once we have that number, 17.4%, this is 17.4%. And then we have this number here, which is 48.95%. Once we have these two numbers, we know lambda is 0.94. We can plug those numbers into this formula here. So that's what we have done here. Lambda times Q7. So Q7 is the estimated volatility. We calculated 17.4%. And then 1 minus lambda, which is 1 minus 0.94 times D7. And D7 is 48%. And once you calculate that, you get a variance rate of 19.24. And if you take the square root, you get the volatility. So the estimated volatility is 43%. Now, one thing to note, because we have a high lambda here, almost a high lambda 0.94, what that means is we are saying we give a very high weighting to the estimated volatility of yesterday, and we give fairly lower weighting for yesterday's price change. Now, if your lambda is small, let's say for example your lambda is 0.3, that means you're only giving 30% weight for yesterday's estimated volatility, and you're giving 70% weight for your daily returns. Now if I make this 0.3, you will see suddenly, now remember for 0.94, we had a 43% volatility. Tomorrow's estimated volatility is 43%. Now what we are saying is, even though we have here 48% daily changes, we are only giving 6% weighting, because 1 minus 0.94 is 0.06, so we are giving 6% weighting for the recent price change. Now if I increase that to, if I put 0.3 here, that means I'm going to give 70% weighting for this daily price change. You will see my volatility from 43%, it's going to jump up. It's going to go to 62%. Now the reason is we are giving a very high weighting for the recent price change. But as I said before, we have industry as a standard has agreed that 0.94 or closer to 0.94 is a more acceptable lambda value that gives you a volatility that is very close to the realized or the actual volatility. So I hope you understood the concept of the exponential weighted moving average model. So you simply need two inputs. You need the most recent price change, and you need the most recent estimated volatility. Once you have these two inputs, you don't need a historical values like I'm showing you here. This is just for just for you to understand the concept. You simply need the yesterday's price change, so that's this number here, and you need yesterday's estimated volatility, which I showed you here, which was 70.4%. Remember, this is estimated volatility, yesterday's estimated volatility. Once you have these numbers, you can estimate the volatility for next day, and based on lambda, you are applying a weighting to these two values here, and that will give you a reasonable estimate for the next day's volatility. Now in another video, we will look at the gauge approach. Now remember, compared to the normal way of calculating volatility, which is simply the average of the daily returns, you could take the average of daily returns and then you take the square root, and then you can arrive at the volatility for one day. Now the difference between that and the exponential weighted moving average model is that you are applying a weighting. In other words, most recent observations get a higher weighting, and observations that are far behind get a lower weighting. So that's the benefit. So in other words, when you're using the exponentially weighted moving average model, what you're saying is that more recent observations has a high likelihood of occurring. Now, of course, what you are not capturing is that if one of those stress events, like I mentioned, maybe a event that happened in 2008, 2007, or a stress event that is far behind, if that occurs again, you might not capture that in your estimate as part of your exponentially weighted moving average model. But for risk management purposes, this is sufficient. Remember, you don't use the exponentially weighted moving average model, for example, when you're trying to calculate regulatory capital. These are for risk managers just to estimate what would be your volatility next day or in next 10 days, etc.